Hello guys, today we'll discuss question 14. The question is an electric dipole has a fixed dipole moment P which makes angle theta with respect to the x-axis. When subjected to an electric field E1 is equal to EI, it experiences a torque T1 is equal to tau K. When subjected to another electric field E2 is equal that E2 is equal to under root 3 E1 J. It experiences a torque T2 is equal to minus T1. The angle theta is first 30 degree, second 45 degree, third 60 degree, fourth 90 degree. Try to solve this question. So the correct answer is option 3. This is because if we try to make the diagram according to the question given to us, that the angle would be theta with respect to the x-axis. It is given in the question with respect to the x-axis, and also it's given that a dipole moment of a fixed dipole moment, that is P, that is given to us. So as we know the formula, P is equal to P cos theta I, that is x-axis, and P sin theta j, that is y-axis. Then it is given in the question E1 is equal to EI. So now to find the torque, we know that T1 is equal to dipole moment into electric field. So putting the value from the above, first and second, from first and second, tau k is equal to P E sin theta minus k. Okay, that is because as we know T1 is equal to tau k. So putting the value of T1 here on the LHS and solving this, then when I multiplies to I and my I multiplies to j, it forms minus negative of k. So that's a direction, and let us take it as a first. And now E2 is equal to under root E1j. It is given in the question. So now we have to find the second torque. So for that we just use the same formula for the P dipole moment into the E2 that we know, as we know the relation of E2 is equal to under root E1 under root 3 E1. So now again T2 is equal to tau K, and now we put the value here, that is for the particular case T2. It is given in the question that T2 is equal to minus of T1, which would be equal to minus of tau K. So we put it in a LHS, and multiplying this we get this, and from the equation 1